Okay, so in our activity that we did yesterday, I asked you guys to start by taking all the cards and putting them in a big long straight line in order by atomic weight. And you'll notice that unlike the periodic table, these cards, they don't have the atomic number on them. And I did that on purpose because when Mendeleev first created his periodic table, atomic number had not been discovered. So I gave you guys just the information that Mendeleev would have had. Then I asked you to put a square around lithium. And I said, please find all the elements that belong with lithium. So we have two properties we're looking at here. The first is this. We're looking for things that react with water. So when I go through here, beryllium does not react with water. Reacts with oxygen, not very reactive. Reacts slowly with metals, unreactive. Reacts vigorously with water. Slightly with water. Oxygen, metals, reacts violently with water. Unreactive reacts with water. Reacts slowly with oxygen, metals, and unreactive. Okay? Then I asked you to go back to that second property, and this one is called valency. It is the ratio of one element to another in a compound. So in our representative element, we have a 1-to-1 ratio. 1 lithium for every 1 chlorine. So his buddies are going to also have that same 1-to-1 ratio. So if I go to the first one that I pulled, sodium, that has a 1-to-1 ratio. So I'm going to call him a square as well. Magnesium, on the other hand, had a 1-to-2 ratio. So I decided to put him back. Potassium, 1-to-1 ratio. So I'm going to make him a square. And then calcium is a 1-to-2 ratio, so I made the decision to put him back. So that left me with 3. I had lithium, sodium, and potassium as my 3 representative elements there. The next one I asked you to do was fluorine. I asked you to put a triangle around fluorine. Here, he explodes on contacts with metals. So we're looking for things that have reactions with metals. Oxygen reacts slowly with metals, reacts violently with metals. Water, oxygen, reacts slowly with metals, reacts vigorously with metals, unreactive. Okay, so again, I'm going to look at that second property. This was a 1-to-1 ratio of fluorine to chlorine. So here, when I got to sulfur, still reacts with metals, but this is 1-to-2. So I'm going to throw him back. Chlorine, on the other hand, reacts violently with metals, and it's 1-to-1. So I'm going to go ahead and make him a triangle. Over here to selenium, slowly with metals, but a 1-to-2 ratio. So I'm going to put him back. Bromine, on the other hand, vigorously with metals and a 1-to-1 ratio. He's going to be a triangle. The last thing I asked for was helium. I said circle helium and find his friends. He was unreactive and he had no valency. So that was an easy one for us because we just go down the line and we find, oh, here's a circle, unreactive, no valency. Going down the line. Oh, here's one, unreactive, no valency. He's a circle. Going down the line. Unreactive, no valency. He's a circle. All right, so once I did that, I asked you to color code these. So we did pink for our squares, so I'm going to do pink for my square. And then we did yellow for the triangles. Sorry, I know I'm making you guys seasick. And then green for the circles. Okay, So then the next step was to look for a pattern. And truth be told, ladies and gentlemen, there were a lot of patterns you could have gone for. Okay? So we could start with the very basic. Green, pink, yellow. Green, pink, yellow. And we got a little problem. Pink, green, yellow, green. And we assume a pink. So we could do green, pink, yellow, green, pink, yellow, green, pink, yellow, with the exception being right here. And we would maybe flip these around. Another pattern some people spotted was that it went color, color, white, 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 white for 5, 3 colors, white for 5, 3 colors, and then we switched to 4. So they said there's something going on here, something's missing in here. So they figured there was a missing element here. Now if you were super smart, I think I had one group that caught this. Our ratios went 1, 0, 1, 2, 3, 4, 3, 2, 1, 0. 1, 2, 3, 4, 3, 2, 1, 0. 1, 2, 3, 4, 3, 2, 1, 0. So lots of patterns. But the ultimate thing that we decided was we had to switch argon and potassium because they seemed to be out of order. So now I'm going to show you this last step because very few groups actually got to this last step. So what I asked you guys to do for the last step was to break this into rows so that all your colors lined up. So what I'm going to do is I'm going to pull in order my cards so that my colors line up. Something's up here. We're missing something in this group. Don't know what. Something's going on here. And then my last one would go here. Okay? So then I ended up with all of my greens and my pinks lined up and my yellows lined up. But we can do better than that. So I'm going to zoom you in. 1 to 2, 1 to 2, 1 to 2. Hey, look, that lines up too. Over here we have 1 to 3, 1 to 3, 1 to 4. That doesn't line up. But here I have 1 to 4, 1 to 4, 1 to 3. So let's see about pushing this over here. When I push that over there, I end up with 1 to 3, 1 to 3, 1 to 3, 1 to 2, 1 to 2, 1 to 2, and then back to my yellows being in line. So I'm missing an element right here. And that's where, remember how I told you to set gallium aside? That is the missing element. And we can go so far as to predict things about gallium. It's going to have a 1 to 3 ratio. It's not going to react with oxygen, or if it does, it's going to be a real small reaction with oxygen. Now, what I want you to realize is what we've made here. And I'm going to move my greens so that it's a little easier to see. I'm going to move my greens over here. Okay, and I'm going to put just a little space between groups 1 and 2. We got hydrogen doing a weird stuff. We don't really know what to do with hydrogen. If you look at this, this is called a main group periodic table. So basically, this is the periodic table without the transition metals in the middle. Okay, and that's what we created yesterday, was a periodic table.